binary search tree, there's a breadth first search method that you want to have in your binary search tree class. So in JavaScript here, we have a class binary search tree, and here's this constructor that each node has its value and left or right children. And it also has this right here, a method that will breadth first search throughout the tree. So like here's an example of a breadth first search tree, binary tree, and we want to implement breadth first search. So pretty much that means you want to do you want to check the layers going like the levels, like Donkey Kong kind of thing. So we want to go 7, 4, 6, 2, 5, 8, 19, 6, 18. That's how you search the binary search tree for breadth search. In order to do this, you're going to need help of another data structure of a queue, which I put in red. So the logic will be something like this. So first, as you traverse the breadth, you just look at the top root node 7, and what you would do is you would enqueue that node, its value 7, or then the whole node entirety, into the queue. And then what you want to do is, in this case, we want to apply a callback function to every node that we do. So what we do is so what we do is we would dequeue this 7, so we pop it off essentially, and then do the callback on the 7. And then once done with that, then you want to, if it has any children, if it has a left or right children, then you want to enqueue those. So we would enqueue 4 and 6. So, and we're in this while loop though, because the queue is still not empty. And then what we would do is dequeue 4 and just do the callback of 4. But that has children of 2 and 8, so they would enqueue 2 and 8. It's getting really sloppy. And then, but then we dequeue the next since it's not empty. Yeah, so it's 6, so we dequeue, so we do a callback on 6, and then no, so yeah, 7, 4. I mean 16. This is 16. So then we would add 8. Right, this should be a connection there. So then we would 8 to 19. I got confused with my logic, but you can see though, each children we keep dequeuing and enqueuing, or when we dequeue, we do the callback, and then we enqueue its children essentially until we traverse the whole binary tree. And that's kind of a, so use an iterative fashion of a while loop, which I did here. So yeah, so here's our queue. Then we want to enqueue the root node of this, and while the queue is not empty, you check out a node which you would dequeue, and if it has any children left or right, then you would enqueue those children to the queue right here like that. And then every time you do that, you want to call your callback function on the current nodes before you move on to the next one's value. So yep, it kind of jumbled. That was my first time voicing it out, but yeah, it's pretty cool. So yeah, anytime you want to do a breadth search with any data structure, you want to use a queue. Queues are nice. So